Good day, so today we will be talking about combination. Combination is the number of ways of selection. Unlike permutation, in combination, the position of elements doesn't matter. So, if you are going to choose green shirt and blue shirt, it will be the same if you choose blue shirt and green shirt. The formula for combination is NCR is equal to n factorial over r factorial quantity n minus r factorial, where n is the number of elements and r is the number of cases. Let us proceed to the first example. So a committee of 3 persons must be formed from 4 men and 3 women. How many possible ways are there? So in this problem, we have 7 elements from the 4 men and 3 women. So the formula will be 7C3 is equal to 7 factorial over 3 factorial quantity 7 minus 3 factorial, which is equal to 5040 over 144. So the answer will be 35. There are 35 ways to form a committee of 3 persons from 4 men and 3 women. For the second example, in a conference of 9 schools, how many intra-conference football games are played during the season if the teams all play each other exactly once? So in this problem, there are 9 elements because there are 9 schools, and in each game, only 2 schools can play. So the formula will be 9C2 is equal to 9 factorial over 2 factorial quantity 9 minus 2 factorial, which is equals to 362,880 over 10,080, which is equal to 36. So there are exactly 36 games played in the conference. Third example, a man has 10 shirts and 5 pants. In how many ways can he select 4 shirts and 2 pants? In this problem, there are 2 combinations. First is the number of ways of selecting the shirt, and the second is the number of ways in selecting pants. So, for the shirts, the formula will be 10C4 is equal to 10 factorial over 4 factorial quantity 10 minus 4 factorial, which is equal to 210 ways. And for the shirts, the formula will be 5C2 is equal to 5 factorial over 2 factorial quantity 5 minus 2 factorial, which is equal to 10 ways. So, for the total number of ways for selecting 4 shirts and 2 pants, we are going to multiply the number of ways in selecting shirts and the number of ways in selecting the pants, since the 2 events are dependent. So, the formula will be 210 times 10 is equal to 2,100 ways. So, there are 2,100 ways in selecting 4 shirts and 2 pants. Example 4. In a party, there are 10 men and 5 women. Each of them shakes hands with the other. How many handshakes were made? In this problem, there are 15 elements. Since there are 10 men and 5 women, we are going to add them because they are all in one party. So, it will be 15. And there are 2 because in each handshake, there are only 2 people involved. So, the formula will be 15C2 is equal to 15 factorial over 2 factorial quantity 15 minus 2 factorial, which is equal to 105. So, there are 105 handshakes. Example 5. In a test questionnaire, in how many ways can 7 questions be answered from 15 items if numbers 2, 4, 6, and 8 are compulsory? So, in this problem, the formula will be 4C4 times 11C3. 4C4 came from the number of ways in selecting from the 4 compulsory questions, and 11C3 was from the 3 remaining questions to be answered from the 11 remaining questions. The answer will be 1 times 165, which is equal to 165 ways. Example number 6. The president of the drama club needs 5 casts for their school play. There are 10 girls and 5 boys in the club. In how many ways can she select the cast with 3 girls at most? So in this problem, we are looking for the number of ways she can select the cast with 3 girls at most. So you can have 3 girls and 2 boys, 2 girls and 3 boys, 1 girl and 4 boys, and no girl and 5 boys. So the formula will be 10C3 times 5C2 plus 10C2 times 5C3 plus 10C1 times 5C4 plus 10C0 times 5C5. So, we are going to add these combinations because all of them are independent events. So, the answer will be 1,701 ways. So there are 1,701 ways to select a cast with 3 girls at most. Example CB. In how many ways can she select cast with at least 3 boys? In this problem, we are looking for the number of ways she can select a cast with at least 3 boys. So, we can have 2 girls and 3 boys, 1 girl and 4 boys, or no girl and 5 boys. So, the formula will be 10C2 times 5C3 plus 10C1 plus 5C4 plus 10C0 times 5C5. We are going to add these combinations because all of them are independent events. It means that the combination of the other does not affect the combination of the other. So, the answer will be 501 ways. So, there are 501 ways she can select a cast with at least 3 boys. In a test questionnaire, there are 2 parts. Each part composed of 10 questions. In how many ways can the examinee answer the questions if he must answer a total of 14 questions and he cannot answer more than 7 questions in each part? So, since the examinee can answer 14 questions all in all and cannot answer more than 7 questions in each part, there is only one possible way he can answer the questionnaire. That is 10C7 times 10C7. The first 10C7 came from the total number of ways he can answer the first part, and the second 10C7 came from the total number of ways he can answer the second part. So, the answer will be 120 times 120, which is equal to 14,400. So, there are 14,400 ways the examinee can answer the test questionnaire. Example 8. In a school club with 6 boys and 9 girls, in how many ways can a committee of 5 be formed if A. There must be at most 3 boys. So in this problem, we are looking for the number of ways a committee of 5 can be formed with at most 3 boys. So we can have a committee with 2 girls and 3 boys, a committee with 3 girls and 2 boys, a committee with 4 girls and 1 boy, and a committee with 5 girls and no boy. So the formula will be 9C2 times 6C3 plus 9C3 times 6C2 plus 9C4 times 6C1 times 9C5 times 6C0. We are going to add the combinations because all of them are independent events. So the answer will be 36 times 20 plus 84 times 15 plus 126 times 6 plus 126 times 1, which is equal to 720 plus 1,260 plus 756 plus 126, which is equal to 2,862 ways. So there are 2,862 ways a committee of 5 with at most 3 boys can be formed. Example 8b. In a school club with 6 boys and 9 girls, in how many ways can a committee of 5 be formed if there must be at least 3 girls? So in this problem, we are looking for the number of ways we can select a committee of 5 with at least 3 girls. So we can have 3 girls and 2 boys, a committee with 4 girls and 1 boy, and a committee with 5 girls and no boy. So the formula will be 9C3 times 6C2, 9C4 plus 6C1, 9C5 times 6C0. We are going to add these combinations because all of them are independent events. So the answer will be 84 times 15 plus 126 times 6 plus 126 times 1, which is equal to 1,260 plus 756 plus 126, which is equal to 2,142 ways. There are 2,142 ways you can select a committee of 5 with at least 3 girls. And that is all for combination.